All right. Go back to screen 4. All right, so this will be recording now. Okay, so what we're going to be doing is we're going to be adding in a couple more LEDs. In order to copy the actual components, I have to have the code window closed, because otherwise it's going to assume that I'm working in the code window. So we're going to add a few more LEDs. Let's see. And this may be more than I want to work with for now, but this will at least get the general idea working. So for every time we're going to use multiple LEDs, you want to get in the habit of using multiple resistors. I'm going to cheat and use the resistors to actually ground these LEDs, remembering cats are bad, cats are evil, so it goes to the negative side. And I don't want to supply positive power for this particular example to the positive rail. Normally that would be coming from here, usually the 5-volt port. A lot of the sensors and things that Arduinos work with can only handle 3.3 volts. Most of them can handle 5 volts, but some of them can only handle 3.3. So you have to be real careful which type of input your sensor needs. All right. So what we're going to do is each of these is going to be connected back to a pin, and the pin numbers are what appear here on the side of the board. So same sort of thing for the Circuit Playground Express. Adafruit Circuit Playground Express. Here we go. So just like what you guys will see, this one doesn't have to be, this can just be a JPEG or really any type. So if we take a look, we have different labels on here. We have the on LED. You'll also see, focus in on this a little bit. We have the on LED. So this will be on when we have power. This will be red, if I recall correctly. And then, or no, maybe this one is green. This one is red. I think it's how it works. D13. So this one is a digital pin. That's what the D stands for. A stands for analog. D stands for digital. So analog is more representative of most of life. This is indicator of button A, button B, different things like that. We have a transmit and receive. We have our accelerometer here on the board. We have our microphone here. We have voltage regulator here. And this is the actual processor, the microprocessor, all the memory and everything. This is the microcontroller itself. This, I think, is one of their timers. And this is our, this I think is the amplifier for the piezoelectric speaker that's on it. And the light sensor is right here. Temp sensor is right here. A number of different resistors and fuses and things, surface mount components. Then our physical switch, tactile switch, the reset button, which is going to become your friend this semester. You'll find out why later. Stay tuned. Couple of diodes to keep current going one direction only. All of the neopixels, so really, really super bright LEDs that are red, green, blue capable, so they can do all kinds of colors. And that's kind of the layout with your power port down here and your USB port up here. So we have all of these different holes that you can connect stuff to, either with gator clips or with metric hardware, carbon tape. You can solder stuff. These are also capacitive touch buttons. So if you're holding onto them with your fingers, they can be used as inputs to the board. So lots of different interesting things, just like the labeling that we have on the Arduino Uno. GND is ground always, and you have several different grounds so that you can have different voltages associated with the board. Okay, so we're going to connect up different pins. And I'm going to keep things a little simple and clean. I'm going to change colors for each of them. The reason that you don't want to use the same color wire is if I were to just start coming in here and doing stuff like this, a lot of you are going to want to try and do stuff like this, and it's just not a good idea. Pretty soon you start getting really convoluted wiring and you start trying to chase stuff down. It just makes a mess. So don't do this. Make sure you're changing wire colors wherever possible. There's lots of colors to choose from. Use some different colors for each different scenario as much as possible. That way, when you're working with things, if you have a relatively straight shot, you don't necessarily have to have multiple different colors. But what you're going to want to do is you're going to want to change the colors of the wires just so that you can visually see, oh, hey, that one goes here, this one goes there, this one goes there. This is going to help you distinguish later on what some of these different versions look like. So, different color wires allow us to much more easily see what's going where, and this is why in all kinds of electronics manufacturing, they use different color wires to go different places. They have wire color codes. They have the same colors, sometimes with stripes, sometimes with dashes, sometimes with all kinds of other things. And those are used so that we can easily find the wires from one end to the other. Unless, of course, you bought some kind of a salvaged flood car from somebody that was a shady mechanic that decided to, just like any good nut job, use the exact same color wire for all of everything that they did to fix a wire harness. And so you have 136 red wires going from one connector to another. That does happen sometimes. If you wire it correctly, it'll work, but imagine trying to chase which red wire out of the 136 you replaced in that harness if you got the pin out incorrect. Don't do that. It's a bad idea. Buy different color wires. It'll save you lots of headache later. All right, so we're done, right? We've connected them all up and we can run it. Oh, nope. Okay, so what do we need? We need to update our code. So starting with step 2, we have a pin mode here. What does our pin mode need to be changed to? Our pin mode needs to be changed to include all of the other ones that we're working with. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need a total of 9 pin mode assignments to go with each of them. So what we've got here, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think we're correct there. All right, so 13. We have them connected to 13, 12, 11, 10, 9, 8, 7, 6, 5, and that's where we stop. So 13, 12, we just update our numbers here. All right, so we've got one extra here. All right, 13, 12, 11, 10, 9, 8, 7, 6, 5. So these match up with all of our outputs. And why do we want these to be outputs? Well, when we're working with something in Arduinos, I want you guys to make a bookmark of some kind here. Starting at arduino.cc, we're going to go to their documentation. Now they have several. one of which you guys want to take a look at closely are the tutorials. So there's lots of examples, lots of things explaining different tutorials and things like that. They have a bunch of built-in examples in the Arduino software that allow you to see some example code for several different kinds of things. So those will be helpful to you. Those are all accessible through the Arduino software. And they also have this reference list. So, hey, pin mode, that's like the thing that we're working with. So let's take a look at it. And so this will explain, this configures the pin to do something, either an input or an output. So input is stuff coming into the board, output is something going out of the board. And this is why we need to know what's actually going on with all of this, because a lot of the mechanics of where we use these include being able to output either to turn on an LED, to move a motor, to move a servo, all different kinds of things. So input is where we're taking data from sensors in, and there's a couple other things we'll learn about later in the semester, including input pull-up. For right now, we don't have to worry about that, but when we start working with Circuit Playground Express and doing button input, we will. So we can also use the analog pins as digital pins. So they just are referred to as A0 through however many we have. In the case of the Circuit Playground Express, we have several. They list, at least out here, externally accessible on the board. They have analog 0 all the way through A7. But you'll notice A0 is also where the piezoelectric speaker is. A9, analog 9, is where our thermocouple is. Or that's a thermistor, actually. Sorry. A8 is where our photosensor is. And I forget which ones transmit and receive are on. Anyway, almost all of those are on analog pins of one variety or another. Okay. Lots of different things that we can see. And each of these neopixels is on a different output from the others. So here we have much more simply A0 through A5. So those are things that we'll need to keep in mind later. And all of this is related to power, whether it's power in, voltage in here, or voltage out, the reset, all of those things. So we'll learn later how to use more of these features on more complicated things. But for now, we've got all of our pin modes set up. All right, so we've got our pin modes set up. Now we need to actually tell them something to do. And this is where I'm going to give you guys the tools for setting this up. We can take this same code and copy it, and we can paste it into different blocks. In fact, what we want to do is actually take this, and we're going to copy this one. As a matter of fact, I'm going to copy the low state. The reason we're going to do this is I'm going to start by doing the first block. This is the most bare bones simple way of thinking about this. Later we're going to start incorporating loops and other things to do repetitive tasks like this. For now, I'm going to teach you how to work in these individual modules. So I'm going to write a comment, and this is going to be called blink 1. So this is going to be my first blinking block of code. And what we're going to do is we're going to set the first one high, and all the rest of them we're going to set to low. So we're going to start with 12. We're going to copy this, and we're going to paste a few more in. So we're going to say 12, 11, 10, and once this is all put together, this will be a whole lot easier to work with. So 8, 7, 6, and we have one more, 4, 5. So that means what we're going to do is in this loop, we're going to start in this first blink. We're going to blink 13, and we're going to set all the other ones to low. Then we can wait. So that's what our delay function is. And if we're confused about what delay does, we come back to the language reference and we go, all right, let's see, where is this? Delay for timing. What's the delay do? This gives a pause and then some number of milliseconds. So 1,000 milliseconds in a second. So we write delay and then milliseconds. They also give you examples in the code. This should look fairly familiar, only they've called LED pin as a name, pin 13. We'll learn how to do this in a little more detail later. For now, we just want to get you guys practicing a little bit. So go back to our circuit, and now we're going to do blink 2. So I'm going to fill out blink 2, but I'm going to do it the lazy way. Okay. The second one. And these have to be all caps. So now, if I write this code, what we're going to see is it's going to jump back and forth. So now we have the beginnings of a pattern to blink. From here, what I want you guys to do is I want you guys to take this same idea and I want you guys to come up with your own unique patterns. And whatever your unique pattern is, I want you to take some screenshots of this. And this is going to be the same format for any of the assignments that you guys are going to turn in. You're going to start from a blank Word doc, and you're going to use the screen capture tools, whatever ones you prefer. You're going to do screen capture tools, something like the snipping tool. This one is always trying to hide back behind the window here. There we go. So if we take a screen capture of our circuit, then we're going to still write our name, class section. Then we're going to see some different sections show up in the rubric for assignments. Unfortunately, I can't log in and easily look at the rubric online, just for a number of reasons, because my side of what LoudCloud shows is completely different than yours. So I'll have to pull up the rubric separately. But you'll see a few different sections, and one of them is going to be, we're going to include a picture of what our circuit looks like. And then we're going to take, so this is a picture showing one of the actions. We're going to take a couple different pictures, and what we're going to do, as long as I can grab this, there we go. We're also going to take a screenshot of our code. So we're going to do the same thing. So if we have to spill onto multiple pages, that's okay. You can do lots and lots of additional pictures, because what I want to see is I want to see what you guys are doing for your code. Just make sure that it's still big enough I can actually see what's going on. The pictures don't have to be huge. They just have to be representative of what you guys are actually doing. So that way I can see, okay, this is what they have hooked up. This is what their code looks like. And that way I can see, are you guys actually understanding how these work? And you'll be able to see with the line numbers kind of where it stopped So what I want you guys to do is from here, I want you guys to build out some unique blinking pattern and show a couple examples of that, and then copy over your code into a Word doc. And that's what you guys are going to be doing for your assignment. All right. Any questions before you guys go to do that? I'll go ahead and set up breakout rooms.
We just turned that in to the blinking LED assignment on LoudCloud, right?
Yes, and that Word doc is what you guys are going to be submitting. So each assignment is going to be a Word doc. Once we learn about flowcharts and things like that, which is going to be starting this next week, and the idea of algorithms and flowcharts and how all of this stuff works in more complicated levels, we'll go into more detail about how to include flowcharts, what those look like, how to build them, what software or websites are easiest to use to build all of those. And then every assignment just about is going to need either a flowchart or pseudocode that's showing kind of the hierarchy of what your program is aiming to do. So in this case, it would be something like turn on LED 1, then turn on LED 2, then turn on LED. So it would just be a stepped sequence with a loop. And that's what this would look like. So we'll look at some examples of how to set those things up later. But for now, submitting things as Word docs with screenshots, both of your circuit and of your code. The circuit obviously needs to be shown doing whatever your pattern is. And then I need to see what your code is so that I know where you guys are grasping things well and where you're struggling. Because believe it or not, it's a lot easier for me to learn that from the raw code. All right. I'm going to go ahead and set up breakout rooms, and then you guys can get to work and I'll jump in and see where you guys have questions. All right, we'll do teams of 3 to 4. Let's see. There might be 1 or 2 of 5. All right, so I'm going to go ahead and open these up, and then I'll stop the record so that I can come check on each of you.